name's Nick. I'm a first year student studying mathematics with music, and what I'd like to talk to you today about is the intersection between those two. It's one of those lovely areas where you look at it from an outside point and you think, how on earth does mathematics have anything to do with this? And you have a look closer and there's so much under the surface. So we're going to go on a very brief history lesson first off. So in the time of the ancient Greeks, you have a slightly different curriculum to what we have now. So they would start off their education with what is called the Trivium, which as it's the basis is where we get our words for trivial or trivia, very basic things. And the three parts of that are grammar, which is basically the input of information, logic, which is the process of information, and rhetoric, which is bringing it out, using the information to make arguments, along with your mastery of the other two subjects. Having studied all of those, you'd move on to another set of 4 subjects called the Quadrivium. And this is where we came to the subjects we know. So you would have your arithmetic, you'd have your geometry, you'd have astrology, and you'd have music. Spot the odd one out, eh? But what you can think about this as is pure mathematics, mathematics in space, mathematics in time, and mathematics in space and time. Of course, they'd have had no way to measure things like terminal velocity or how fast a car is moving while people jump out of the back, changing the mass, and so forth. So they studied the planets, how they move through the night sky. And the study of music there is an interesting one. Mainly deals with harmony and which notes sound good together. So this is a brief introduction to a keyboard in case anyone isn't familiar with them. So you have a whole bunch of notes along here. You have the white ones, which have letter names going A, B, C, D, E, F, G, and then you go around A, B, C, and so on. Circles around. These black ones in between them will give you a note in between. So this one, which is between A and B, we could call it a sharpened A, or we could call it a flattened B. And these all make different tones that come in between the white ones. Now, the point of music is to make notes that sound good together, play together. So for example, if you take our A here and play a second A with it, really sounds like they belong together. It is more or less the same thing but a bit higher. And the reason for that is that if we take a look at because all a note is a frequency, it's a tone being repeated so many times a second. So these are the frequencies of the notes on the keyboard. So our A is at 440 Hertz, and if you double that frequency to 880, you get another A. If you double it again to 1760, you get another A. Starting from, say, a C, 523, yada yada yada, if we double that, we will get to our next C, 1046, yada yada. So you can see that every time we double the frequency, we go from one letter to the next, to the same letter further. Another pair of notes that sound good together would be a note and one 7 above it. So for example, our A, and we go up 7, 1, 2, 3, 4, 5, 6, 7 to an E. And they sound nice together. Now, not all of them will sound nice together. If I play you these two together, yuck. If I play these two together, yeah. So, what we're looking for mainly is these relationships, these things that sound good together. How do we get them? So, looking back to this, if we increase our frequency from the A to the E, that was the one that sounded good with it, that's 440 and very nearly 660. So if you think about it as being times 1.5. And let's take another one. Let's go from our G. If you multiply that by 1.5, approximately this 1174. Let's try G and D together now. That sounds pretty good. So I think we've got a relationship here. You go up 7 notes, and which has the result of multiplying the frequency by very close to 1.5. Now, if we're aiming for 1.5 to get the frequencies to match up, why not just do 1.5 exactly? So, if we were to have, instead of this relationship of weird point whatever numbers, why not have 1, 1.2, 1.3, and so forth. So we have our 1 to 1.5 times 1.5, that works great. We have 1.2 to 1.8, works great. But then that does break down when you start from a different one. Say if we wanted to start from this 4th note here, if we multiply that by 1.5 to get a note that sounds good next to it, you'd be in between these two. So unfortunately using linear frequencies wouldn't help with that. So the relationship is that going from A to A is doubling, and we have a total of 12 steps in between. Each single step is multiplying it by the same number, so that turns out to be the 12th root of 2. You expected to see that, haven't I? And why the 12th root of 2? That is because it has to be exponential, so that each increase is the same multiplication. It has to be 2 to the something, because we're going from A to A and we're doubling. And you notice that 2 to the 7/12 is 1.498, which is very, very close to 1.5. If we instead have 13 steps from A to A, then the nearest we'll be able to get is 1.542. If we had 11 notes in between A and A, the nearest will be 1.459. So having 12 steps means that we have this note partly in between, which has an excellent relationship with the note we started on. And it also means that we can start from any note and go up by 7 notes to have this same 1.5, no matter where we start. And that is why there are 12 notes on your keyboard. 12 notes on your violin, on your saxophone, your marimba, whatever. And we can look at this again in a different way. So if we rather than just looking at the 1.5, which would be the simplest fraction between 1 and 2, look at the other ones as well. So this is just taking, say, 523 over the base note of 440, which would give 1.189, and within a 1% margin of error, that is 6 over 5. So that is again a fairly simple fraction. If we go from A to D, that's a multiplication of 1.335, very close to 1 1/3. And you'll notice that some of these fractions are quite simple. So simple fractions will mean that our base note and that note will, when played together, they will sound at the same time more often. But if you have slightly weirder fractions like our 17 over 12, that means they're not going to coincide as often. So that one we think is going to sound awful. So that would be A as far as D sharp, and that one was the awful one earlier. And we have a look at A to A sharp as well. That's another dreadful one, 16 over 15. So the simpler the fraction on the right, the better the notes sound together. And now we can look at making a series of notes that sound good together. Because you wouldn't just have 2 notes in your song. So we start on our keyboard here. We're going to start from C on the far left here. And we're going to use our 1.5 relationship several times in a row. So we'll kick off with our C. Next one up will be a G. Times 1.5 again will be a D. Going up 7 will be A, and so forth. And you eventually get this. Now there's one thing to point out. 7 and 12 obviously have no common. F sharp would be the awful rubbish sound we heard earlier. So So what we do instead is we pretend we're going to F, so we go by 6 notes instead, and then that leaves us our final gap of 7, which perfectly lands us back on a bass note. So putting all of that together, I'm going to write them in a slightly different order. So we started on C, we added a G, next up was a D, we want an A, we want an E, we want a B, and lastly we add an F. So we've got a series, we've got these 7 notes, they're all going to sound relatively good together, just built up from our relationship applied several times, and that's given us a set of 7 notes. There's another way you can build this up. If we go back to our set of frequencies here and we choose simple fractions. So we'll start off with A. Simplest fraction is the 3 over 2, so we'll have an E. I'd say the 4 over 3 is next simplest, so we'll have a D. 5 over 3, 5 over 4, those both sound simple, let's add those in. So that is F sharp and C sharp. What do we have C? And down the bottom we want 1 between the 5 over 3 and the 2. This is the simpler of the 2. So we'll also have a G sharp. What I'm going to do lastly is just add in the note we started on. I'll have that one twice because it's the note that we're building everything on. Let's try playing this. So is it going to sound good? So this is something we build up just from looking at the mathematics behind it and the frequencies. So the top one. Let's try the second one. So we have built this relationship, which is a major scale, and you can start that from any note you like and it will sound the same. Let's go from a B instead, so we'll have the same chords, which is notes at the same time. You wouldn't just be playing your scales all day, that would be quite boring for the audience. So sometimes you want to play these notes that sound good together at the same time. But if you're just having the 1.5, that's all the time, that's going to sound a bit dull. So it's the same thing. So what we want to do then is add something in between. We want to add a note in between the lower one and the one 7 steps above. So the one we choose then is we want it to be roughly in the middle of the C and the G there, and we want it to be one that is in our major scale. So E is in our major scale, so choose that one. This one, which is E flat, oh my goodness, is it good? That one is E flat or D sharp. That one is not in the major scale, so we don't want to use that one. You could use the D or the F, but they are quite close to the ones on the outside, so it sound quite ambiguous. So the one we've chosen is the E, so sound all those together. Or we could alternatively have the D or the F. But it sounds like it wants to go to the first one. So starting on different notes, again, you have your note you start on, you go up 7 steps to give you this 1.5 relationship. Sounds good together. And you pick one in between that is part of your major scale. So here we have D, F, and A. And that's what's called a minor chord. Where you had 4 steps here, we now have 3 steps. and that gives you a bit of a sadder tone, so you can vary the emotion during the music. And other chords that are frequently used in music are ones that start on the 5th note of the scale and the 4th note of the scale. We can notate these chords by which degree of the scale they start on. So that'd be 1, 2, 4, 5. And you can fill in the gaps, but these chords are the ones that are commonly used in music. As a matter of fact, pretty much any pop song, you'll just see 1, 4 and 5 repeated ad nauseum. Lengths. You wouldn't want to have the same note being played at the same length all the time. You want to add a bit of variety, a bit of rhythm to it. I hate Internet Explorer. Right, so what we have here is what's called a time signature in music. And is that like anything like a mathematical thing we've seen at all? I'd say yes. And I'm going to do something which will be blasphemous to anyone in the room who studied music. I'm going to call that a fraction. So we'll put a little line in between them, and we'll say that 4 over 4 is equivalent to 1. We can have another time signature, 3 over 4. We'll call that equal to 0.75, 3 divided by 4. And these are other time signatures, 7 over 4, 12 over 8, and we can just represent those with numbers. On the right, we have the notes that you may have seen if you've seen any music. And these have different values, so whenever you see this one, it's equivalent to 1 worth of note, so that's a long one. This one will be a half note, 0.5, 0.25, 0.15. You can add a little dot after any of these and multiply the value of it by 1.5. So if we had this one here, the half note, with a little dot next to it, that will be 0.75. And what we want to do is have a collection of these notes so that the values from them add together to make our bar. That's what it's doing. Right. And now for everyone's favourite part of the presentation, audience participation. I don't know what your ones. Right, so I'm going to have a few rules for this. I'm going to mainly just guide the process. You guys are going to provide the input. You're going to make the song. So, what we want first of all is a note to start from. So can I have someone pick any note they like?
E.
E. Can I have it in the key of E? Okay. So, using the relationship we found earlier, we can make the major scale from that. So we could do it with fractions, or we could just do it from memory. So the notes in our scale would be E, F sharp, G sharp, A, B, C sharp, D sharp, and back to E again. And what we also want is our common chords, which is the 1, 4 and 5. So our 1 chord will start on the first degree. So that is E, go to the G sharp, and then B. We also want to have our 4 chord, starts on the 4th one, 1, 2, 3, 4. So A, C sharp, E. And another important chord is 5, start on the 5th degree, is B, so we have B, D sharp, and that will go round to F sharp. to go home at the end of it. This is the chord that the whole music is built on, so we want to return to that at the end. So. Right, so we're going to start in our chord 1. Now, on the main beat of the bar here, we definitely want something from that group 1 there. So we want an E, a G sharp, or a B. On the ones in between the beats, you can use other notes, but mainly we're going to want to be using those 3 notes in this bar. So let's just go around the room in order. So we want to pick a note, and we want to pick a length for it as well. Just put it here. So. So those are our common lengths. Right, let's start with B.
A B.
We're going to start with a B, and how long do you want it to be? Okay, that one has, I'm just putting these onto the music. Unfortunately the sound's dead in here, so we're going to have to play on the piano at the end. So we're starting off with A and B. I'm just going to change the key signature one later. So this is now put 4 sharps here, which matches the 4 sharps that we have in our major scale there. Okay, go around the room. Next note.
G sharp.
G sharp. And how long do you want it to be?
How long is the first one?
That's a quarter.
Another quarter.
Okay, next.
Let's go for an A half note.
Half note. Okay, now we want to be choosing notes from our 4 section here.
C sharp.
Going for a C sharp. Okay, how long would you like it to be?
Semi-crotchet. 8th.
8th. Okay. Okay. Now I'm going to guide it a little bit here. We want to end up back onto the bar, so perhaps using another 8th note here would be a good idea. What would you like it to be?
She's C sharp at the moment, isn't it?
Yeah.
Go down to G or G sharp? G sharp, please.
We want a G sharp. Okay. Right. Now we're back onto the bar, and what note would you like?
A
Okay. And how long would you like it?
quarter.
Right, next one. This is one on the beat. It's going to be a strong one. What would we like?
F sharp.
Okay, I'm going to overrule that, I'm afraid.
I don't know.
We're on a. This is the point exactly halfway through the bar,
Alright.
so we're definitely going to want one that represents the 4.
Okay.
So we want an A, a C sharp, or an E.
C sharp then.
C sharp. We're now in the 3rd bar. This one should look a little bit like the 1st bar, but not too similar. So we're going to want more or less the same lengths, but not exactly the same. So I'm going to pick the length for this one. It's going to be a dotted quarter note. You can pick the letter there.
G sharp.
G sharp.
Hmm.
We're now in the 3rd bar, which is this one here.
B.
B. Okay. Okay. Now we're going to want 8th to get back on track. we're on the strong beat, so we definitely want to be a D sharp or an F sharp.
F sharp?
F sharp.
Not bad. No, it's just the way it's going, it would make sense to do a D because then it'd be a step, because steps are always nice. But I'll just sit here.
This is an experiment. What we're trying to see is, we're going into this with very little musical knowledge. We're applying the rules we picked up from the maths side and seeing if we can make music out of them. So I'm going to go. No thanks. I'm going to go with the original suggestion. It was, you said F sharp, yeah?
Yeah.
F sharp. Right. And one more note here.
D sharp.
Okay. Right, this is our last bar. So we're back to E, G sharp and B. And I'm going to make one last rule that we need to finish on a long E, which is the note that the whole piece of music is built on. So that will need to be at least half a bar, but we can have a bit of room to play with first. So what would we like in this bar?
G sharp.
G sharp. What would you like for your second last note?
Go
Have
for
the same
B.
thing twice if you want.
B.
Going for B. Oh, no, that's not good.
That's G.
And that is a D. And we're finishing on a long. Right. Does that look like a mess or does it look like music? Let's find out. Is anyone really good at piano? Because I was kind of expecting to be able to just make the computer play it. No? Okay. Okay. I think it sounded like music. It sounded like it had a beginning, a middle, and an end. We went around the houses a bit, we explored other notes, and we got back to where we started. Apart from the minor kerfuffle in the middle of the song where I forgot how to play. So well done guys, you provided the notes, you made a piece of music, and just to remind you, we built our major scale just from mathematics. We looked at our note lengths from a mathematician's perspective. We found what chords we're in by looking for frequencies, what sounds good together. Very little music knowledge, and we've made a bit of music. Well done, all of you. I'll be sticking around a bit for questions, and I believe there's some squash and biscuits as well. Thank you.
Oh, thank you. Does anyone have questions for me?
We chose E.
Yeah.
And then there was also the other one that went C, D, E, F, G, A, B, C. So why did they both had E's in, so how did you know which one to choose?
The one you picked, we picked an E,
Yeah.
so we're starting from an E, and then we are applying. So if we were to look at our frequencies and start from an E instead, and have these fractional relationships, then it will give us these notes here, the E, the F sharp, the G sharp. If you were to start from an E and go up by 7 steps each time, you would highlight some different notes and you would end up with this set here, the E, the F sharp, the G sharp and so on.
Even though E is in them, E is in that
Oh,
one,
yeah,
you
yeah.
get different. Okay.
He is going to be in more than, if you start from any note, there's a more than 50% chance that he's going to be in there somewhere. Anyone else?
I have one.
Oh, please.
If you go back to the frequencies chart,
Yes.
so when we calculate the fractions, we
Yeah.
get we get an approximate value of those fractions. We don't get those fractions exactly. Is that because the piano can't be tuned perfectly, or is it? Or is there some other reason?
Okay. The reason is that if we did have exact ones instead, then it wouldn't quite match up. When you start from, it would work fine if you were always starting from here, but you know, we've got a bunch of notes on the keyboard. Sometimes we want to start from a different place. So if we were starting instead from this fourth note here, we multiply by 1.5, you end up wanting to play something that's in between two notes. So that's why we have to fudge it a little bit and go for these ones which are extremely close to the fractions we want. The key one in all of this is the 3 over 2. That's the simplest fraction between 1 and 2, and it's the relationship on which everything else is built. You'll notice that, okay, so if you go up 5 steps and then you go up 7, that takes you to 2. If you multiply the 1 for 5, which is 4 over 3, multiply that by 3 over 2, you get 2. If you go up 5 steps, then 5 steps, then 2 steps, 4 over 3, 4 over 3, 9 over 8, which gets you again to 2. It's all interlinked. Does that answer?
Yeah. Thank you. Can we have another round of applause?
Yeah.